look at comparison between the AI and human beings have taken 3 million years to evolve and up to the natural selection and finally got this vision. AI has been around only 1956 Dartmouth Conference and today it is already making wonders. And it is already 90% time correct. I want to share with you what doctors misdiagnose AI diagnosis through the computer vision. The finding is this: computer vision recognizes both men and women, the gender part, differences. Human beings cannot differentiate between the retina of man and woman, number one. Number two, it can predict whether the person is having a retinopathy or not. That is one thing, that's very easy. But the second one is about the risk with the heart, cardiovascular disease, about the mental disorder, about the kidney problem. So computer vision can tell many things that the human beings miss. So they are equipped with the very unique potentiality, as we are trying to put it. And look at ChatGPT. It has 155 IQ. It is able to solve many problems that we are not able to solve problems. Of course, it has nothing much to do with the vision, but the brain, and compared with the human beings and their thing, it has been around only for, let us say, 56 or 70 years. But it's still doing a lot of wonders. And look at the way AI is processing the information. It is doing almost at the speed of light. But the brain is processing at about, let us say, 300 or 3000 or 5000 Mbps second. So maybe it is around for only for a few years. Over a period of time, with 65 years, it is making people jobless. And if you look at the AGI stage, AGI we are going to come. Now we are in ANI. And when human beings are able to solve all the problems, I mean the computers can solve all the problems like the human beings, AGI. And we are saying it's around the corner, maybe about 2 to 4 years from now. According to Grey's for 2027 or 29. From ANI we go to AGI, where the computer will do all the problems, solve all the, perform all the tasks that human beings can do. Maybe it's just around the corner. While I appreciate the unique innate nature as a doctor, about the unique potential of the human being is a wonderful machine that ever created. No machine can beat the human beings. But having said that, but already AI is scoring over many things, and even if the 65 to 70 years of journey, it is beating 90% of the time. Well, I think that also needs to be looked at. And like I said, computer vision is diagnosing where the doctors are missing the diagnosis. So what do you have to say about that?
So this has always been the promise of AI, which has never been realized, which is that it's going to reach AGI and become smarter than humans. My counter, or rather what I would say, is that we've never been able to really successfully put a human out of the loop of the AI in terms of real world deployment. So in the sense that, let's say AI is making a diagnosis of some retinopathy. Now AI is making the diagnosis.
Vision.
Correct.
Computer vision is scoring over the human vision.
Yeah, so those are domains where usually we don't have any direct domain experience. For example, retinopathy, none of us would have seen a retina image. And so the AIs are able to diagnose certain differences which we probably cannot. The only problem is that sometimes you have these very weird issues with AI where all the images from a particular clinic, it will do 100% accuracy. You change the clinic and suddenly the accuracy goes down a lot. Whereas a human, for example, in the same domain, they might have been trained to spot retinopathy of a particular kind in one clinic. They will be generalizing much better to out of domain sort of data. And so there's still some weirdnesses about AI. All I would say is that I'm not here to really discuss demeaning AI. It's really, I think, whether AI is going to be smarter than us. I think we still need to understand the human brain. And so to some extent our enterprise anyway remains unaffected in some sense, because we like to get a deeper understanding of AI. And if you take for example ChatGPT or some AI today, the internal workings of ChatGPT, even ChatGPT themselves, OpenAI themselves don't exactly know. They'll just say, okay, we'll just throw some more data, put some more guardrails and all that, but they don't know the internal functional components. And so that's what actually as scientists we're trained to do, is to dissect out the circuit and poke and prod and say, okay, that's the functional working piece, that's the worst piece that's not working, that's the part that really is working. And so we got to put all those pieces together. in some ways a lot of neuroscientists are going to AI algorithms and saying, okay, let's try to understand it like a scientific problem. What makes it actually work? So I don't think it's a question about like whether what will AI do in the future. Let us look at where it is today, and then what we can do to improve it, what we can do to use it to understand the human brain. Those are all I would really say. I don't think we need to get into whether it will become better in 2 years or 5 years or 10 years. That's always been a matter of debate, and actually there's also vested interest behind it, because the companies that are promoting AI would want to say this to get all their investment. I mean, the amount of capital investment into AI is massive, right? I mean, imagine that amount of investment going to basic education or like higher education would have worked wonders. So yeah.
Job layoffs are really a big. Job layoffs are going on.
I mean, like
all the jobs are going. There's a proof on
correct.
mass layoffs.
Yeah, all the things that we think are hard to do are being replaced. Yes. Yeah.
So one your facial recognition part of it.
Yes.
So you said you also said some of the parameters you gave, like lips or the face.
Correct.
Suppose you have also conditioned the human brain with the same parameters. Saying that okay, these are the parameters on which I think you should be making you identify. How does the correlation look like in that situation?
Correct. So we actually did a sort of study at that time when you were studying this problem, because we found a bunch of people who could not do this task. They were actually a chance on the task. And when we asked them about the task, then we said, okay, can you categorize people into South Indian, North Indian and do this task? They said like, yeah, maybe. I mean, some people said they could do, and it turns out that they couldn't do. Some people said they couldn't do, and they of course couldn't do also. We tried to teach them by giving them examples. And some people were able to learn, and we sort of had this idea that if you had a kind of nice representation in your brain, then you would be able to learn much better. But I don't know exactly how we learn this task. So for example, there's a lot of there's a lot of implicit learning, and there's also explicit learning. Explicit learning is giving labels, but the implicit learning is using the memory of past labels to sort of bootstrap your features, and like you got enough training examples, so you say, okay, the mouth should be like this or the nose should be like this. There's some internal rewiring which is also happening, which I don't know. So we've tried to study it, but we don't have a good answer.
The other thing that in terms of you said again, it's a brain study what you're doing, I think, trying to understand how the brain works, right? See, again, even if it's not a spiritual thing, I think there will be some memory which is left in the DNA, right? DNA is a kind of memory. So, are you able to study something which carries? I think all of us, from the ancestors and generations, I get to doctor, I think it's called million years, I think it's what carrying, right? That probably can give some solution to the problem how the things are working.
So, in neuroscience, people have done these very strange kind of studies which I don't know fully. Like, I've not studied biology very deeply, and so, but there are these very fascinating studies which are called about with an epigenetic inheritance. Basically, what happens is the parent will undergo some experience, and that the experience is actually transmitted to the offspring. But there's a very, very specific type of things, and it's not the memory that we are all thinking. Like, for example, you remember some grandmother, and then like.
That's not the memory.
So it's actually some other kind of memory.
Recognition kind of memory.
Yeah. So I'm not sure to the extent to which those kinds of things, whatever people have studied, are actually very, very strong memories, like a fear memory of like one particular auditory tone or something. Very, very strong memories that are induced, and then they found to sort of go into the offspring. Very interesting studies, but I actually find biology very complicated, and so I think you should ask some of our biology and genetics people to really sort of explain some of those. But what I would say is that there is still some space where we would like to know what is the final format in which the brain is doing this kind of processing. And if we know the final format, we can go and investigate it genetically, or look at how that's being built up. But at this point, we don't even know the final format, is what I would say.
One last question, sir. I think so that Monkey explained what this is, right?
Yes.
So you put an electrode, right?
Yes.
So already you have kind of interpreted it, right? It's not natural.
Yeah.
Is there any way you can do it without actually including it?
At this point, the kinds of technologies that we have right now with us, there's no way to non-invasively brain, image the brain.
You conditioned it then?
Correct.
Some impact. I don't know how
So,
serious impact is.
as far as we can, the electrode that we insert is actually about the thickness of a human hair. So it's very tiny and.
But it is conscious, right? I mean.
Correct.
See, like even if somebody puts me in an ECG,
Correct.
I mean I'm conscious that somebody is monitoring.
Absolutely.
Me, right?
So I mean it's a bit of a kind of what I would say is a bit of a trade-off in the sense that we'd like to be able to understand things at a very micro scale. There may not be any better way to do it, and sometimes some of those kinds of studies do reveal a lot of deep understanding, and so to some extent those kind of studies.
So my question is, do you do any correcting factor for those interviews?
Not particularly, and from whatever we can tell in our data, we don't see that kind of impact on the study itself. So, for example, we don't see any difference in the behavior. We don't really necessarily see any change in the processing. So, a lot of it seems to be a fairly stable system. So, we are able to interrogate.
Thank you.
Like humans beings using things, get two statements. Humans using things, especially for computers, it's becoming difficult to recognize that. Maybe it is because we are not able to develop such complicated algorithms.
Yes.
So that is why we are not.
Correct.
Maybe the fault lies with us because we are not able to develop such systems.
Yeah. No. So, I mean, all I'm saying is that if we are able to create AIs that do all these things, then how come we haven't created AIs that see? So, there's no agency being given to AI that it's not its fault because we are the ones who are creating it.
Coming to this,
So,
definitely AI can do those stuff. That is my assumption.
we would all, I mean, I think there's a polarizing debate because a lot of people think that maybe AI will never get there, and there are a lot of people who do think that AI will get there. I would say that, I'm a realist, so I look at what is actually there, and then whatever is actually there is nowhere close to like actual, what people call as artificial general intelligence. That level of intelligence is not there in AI right now. Right now AI is learning and speaking Shakespeare because we felt like, the AI algorithms have digested the entire internet, right? Of course they can solve like JE problems and all that, but the point is when you put them in a very new domain, they often don't behave the way we expect. For all the knowledge that they do exhibit, they don't seem to generalize to certain domains. Real world applications are not really coming out there like that. So I don't know. I guess it may.
But to do some experiment, you are having a group of students from your institute.
No.
So will I get a chance to become a subject in your experiment?
I've sent, please search for Indian Face Perception Project. It's an online experiment we are running right now. So you can sign up for the test. It's a free test, you can take it online, and it's a face recognition test actually. And so please do participate in that. And we're very happy to, if you spread the word, ask your friends and family to participate and all that. And because this kind of sort of exercise is not being done for India. And if you assume 2-3% of Indians are actually face blind, there's a huge number of people who are possibly face blind. They don't even know that they're face blind. It's a bit like when you don't have specs and you're actually in school, you think that everybody sees a blurry chalkboard and everything is blurry to you. And when you wear the specs, you're like, oh my God, this is what I've been seeing. So that, I think there's at least a small set of, there's a large number of people because India has a huge population. So there will be a lot of people who are actually face blind and they don't know it, but they won't go to the doctor for it because these are things where they just cope with that disorder. They don't go to the hospital because they're able to cope in other ways.